Okay, Larry BL here, and we're going to be checking out the wiring before I get ready to loom all this up and make it look pretty. So the first thing I wanted to check is I've got my multimeter and I've got it hooked to the battery ground. So the connection that we want to check is this little guy right here, and this plugs to the engine coil pack to effectively ground it when the switch is turned on or turned off. So I'm going to connect the multimeter here, and as you can see, I've got a full swing, which the switch is in the off position, so I'm going to put it in the run position. And you see the multimeter went to open. So when I turn the ignition switch off, it grounds the coil pack. So that shows that we are actually good there for shutting the engine off. So that'll be the first check. Alright, this is my setup to test some electrical. What I have is a little 3 amp AC transformer. It allows me to get the AC taps here, so later on I can check the dual diode pack, and then I run it. I can run either 14 volts or I can run 28 volts. Right now I've got it hooked up for 14 volts AC, feeding a bridge rectifier, coming out to my terminal ports, and I am showing 14.4 volts unloaded on my voltmeter. So that should give me plenty to test the solenoid and the lighting circuit. So hopefully I'll get some tests going here and get up a video and some pictures. Thanks for watching. Alright, I ran into my first snafu, and that's the benefit of using a 3 amp power supply, because if you short it out, all you're going to observe is a voltage drop on the meter, a little bit of sparking maybe, but you're not going to burn anything up. So the snafu was on the tail lights. I assumed I was going to try to wire them as a positive ground for future LEDs. That wasn't going to work. So I had to reverse the wiring on them because it was causing a dead short. And then I've got this lighted rocker switch that I was trying to get set up also. So after a little bit of rewiring, we have the lighted rocker switch, and the tail light circuit is now working. So that's what I wanted. I wanted the lighted rocker switch and the tail lights to come on with the headlights. So that wiring circuit, lighting circuit, now checks out. And I'm going to move on to the next circuit. Thanks. Okay, had to work out a bug in the safety circuit. So basically down here is the clutch safety plug, and it was actually moved over one, so I was having to troubleshoot it down. But where I'm at now is I've got the voltmeter connected to the positive that goes to the starter, which just goes up to the solenoid. So the safeties run on the other side of the solenoid to kick it in. So now if I go over, and you should hear it click. So that's how I get voltage to the starter. That's the solenoid clicking. So we got that ironed out. Yeah, it's just makes this a lot easier. That way when things get put together, you're not having to chase wire gremlins around, just to test things out one at a time as we get this thing loomed up after everything's checked. Be back in a little while. Alright, we got another test here. This time it's the PTO, and since I did separate grounds on all the connectors, you have to remember now to hook your meter up to the negative and positive on each connector. This goes to the electric PTO. So we've got the digital voltmeter watching the voltage, and look at that glare. How do I get rid of that? There we go. So the analog voltmeter is watching the PTO, so I'm going to turn the switch on. I've got voltage going to the PTO connector. So that test is good. We know we got voltage to the PTO connector. Alright, we've got one more thing to test, and this is the seat safety switch. Now, I had to wrap my head around this one a little bit because what we have here is if the seat is not occupied, the switch is closed, which I did verify the switch is closed. But why would that be? Because when we've got the PTO turned on, it goes to this relay, okay, and with that relay energized, it opens this relay switch. So basically what happens now is I've got a light bulb hooked up to the PTO where the PTO would be on. So I flip the switch on, I've got power going to the PTO, but if you look up here, this meter is connected to the kill switch on the engine, which shows it is shorted or grounded, which means the engine is shut off. Now, let's get this where we can see it without a glare. So now I'll reach up here and I'm going to push the safety switch as if the seat is occupied. So now the seat is occupied, which means the engine will run. So basically you're in the seat, you've got the PTO turned on, the engine is running, and it is allowed to run because the engine kill switch is open. But if you stand up while the PTO is on, boom, the engine shuts off. That is the only deck safety switch on. I guess they figured they needed it in 1988. But again, the operator present relay kind of throws a little wicket into that. But overall, everything's working as it should. I do have one more switch that I'm trying to figure out, and we'll cover that here shortly. Thanks. Okay, this should be my last issue, but this one might take some thought. So, up here on the solenoid, we have the battery terminal coming from the battery positive. Then I have this orange wire going to a 30 amp fuse, which goes to the amp meter and over to the ignition switch to run all the electronics. But where I'm going with this is I've got another red wire here. This is marked for my future LED lights. This way they'll run directly off the battery even with the engine shut off. This red wire goes up to a 5 amp fuse and then directly into a switch. And then the red wire comes off of the switch and then comes down. Let me find it here. Bear with me. Right here. So here's my red and black grounds. This would be my future connector for my LEDs. And if you notice, the red wire is not hooked up to anything. Okay, and I'll hold this in my hand to make sure it doesn't touch anything. But if you watch the voltmeter, I'm going to flip the switch on. I get a 2-volt drop. The only thing I can figure is there's some internal resistance or something with the switch, so I may have to get a different switch. So if you can think it might be something else, let me know. But for right now, I think I'm going to have to replace that switch, because 2-volt drop off a 3-amp power supply is kind of ridiculous. So that's going to be my next thing, is probably picking up a new switch for this and putting it in. Thanks for watching. Alright, I changed out that switch that I'm going to use for my LEDs. Apparently there's some internal resistance on it. I don't know what's going on with it. Here's the new switch, and if we watch the voltmeter, switch is on, off. So we're good to go now. I don't know what was going on with that switch. So now that all the electrical is checked out, the next step is to loom it up. So I'll get it all cleaned up and loomed up, and next step is going to be probably cleaning the electrical bench off and beef it up a little bit and get the engine over here so we can get an engine in this thing hopefully pretty soon. Alright, thanks for watching. Alright, for the last test is the charging circuit. So, I'm sorry this video may be a little long. So, per the specifications from the stator, we're looking at needing 22 volts AC. So, this is a 28 volt AC transformer. And if you notice down here, we're not using the center tap. I'm actually coming off the full 28 volts. And I'm feeding one that would go to the engine ground, and the other one is coming over, sorry, don't need sparks, and this would be connecting to the stator. I've got the multimeter connected to the positive battery terminal and the negative battery terminal. So we'll come over and we'll turn the key on, and as you can see, I've got 14.4 volts. Be a little bit less with the 28 volt or 22 volt stator, but if we come over here and we turn the light switch on, we have lights. So this is actually on the other side of the dual diode. So one diode is feeding the charging current, and the other diode is feeding the lighting circuit. So I'm pretty happy with everything that we've done so far. Tells me all the wiring is good. After having to fix a few things, reversing the leads on the tail lights because of a previous mistake, finding out that the brake safety switch wasn't plugged in correctly, and fixing the future LED light switch. Had to actually replace that altogether. So with that said, I got to retool everything to start engine work and finish looming this up. So I'll work on putting this video together and get it posted. And a long week at work, so next weekend hopefully I'll be retooled to start doing engine teardown. Alright, thanks for watching. Okay, I think there might be a little explanation needed to be made here. So this is the wiring diagram on my particular tractor, and I won't go over all this side here. Mainly all the positive stuff are individual points, but what I want to point out is this chassis ground. And if you notice, all the components are tied to the chassis ground. So they're using the chassis and all the bolts that ties from the battery negative to the frame for the ground side. And this can cause issues if you get some corrosion on a bolt from like the dash tower where the battery is normally bolted down to the, for example, the lighting circuit or the starting circuit or the charging circuit. This basically using the chassis for the ground can be problematic. So what I've done is I've tied all my grounds for every individual item into one bolt. So everything that requires a ground comes back to one single ground point that's tied to the battery. And then I've also got a 6/0 that comes all the way down to the engine frame bolt, and then I'll have a separate ground that actually ties to the engine block. So everything goes back to a single ground. Takes a little bit of effort, but it's not that expensive. So I'll cover the testing of this electrical system now. So bear with me, this might be a little long video. Thank you.